All right, on we go. The part of the atom that's involved in chemical bonding is the electrons. Electrons. And so they will move, that's how we get those ions when they move like that, to do chemical bonding, how we make water, sodium chloride, salt, etc. So I do need you to know the difference between an ionic and covalent bond. An ionic bond is actually almost like an electron theft. We say it's a transfer of electrons. It's how we get those ions. One thing gains electrons, one thing loses an electron, so you get a cation, anion, and then they actually stick together like magnets. They become positive, negative, stick together, magnetized almost. So the prefix co there actually means to share, co-workers, you share work. The word valence is your outermost electrons, the ones in the outer shell of the atom. So they're sharing those outermost electrons. So this is sharing of electrons. All righty. And then we have two flavors of sharing. And I don't know if you've ever shared with anyone. There are multiple ways to share. I had have two children, but when they were younger, sometimes we would buy something and they would have to share it. Sometimes they were nice with each other and they would be equally share, and sometimes they would not. When they did not equally share with one another, one person came a little bit mad and one was more happy. So this word polar, I don't know if you know what poles are on a magnet, a north to south. Poles means like opposite things. So a polar covalent is still sharing, but it's an unequal sharing. Unequal sharing. So what happens is one atom becomes one becomes positive and one becomes negative. So we say that it has poles. That makes a difference when things go across membranes and stuff for polar covalent. Sometimes polar covalent can't go through certain types of membranes and they have to have gates and channels to go through. A nonpolar, nobody gets upset. So nobody gets upset with nonpolar because that is an equal sharing. So because it's covalent, it is sharing. And I'm talking about of electrons. If you get equal sharing, you don't get one side positive and one side negative. So that makes a difference. And we'll be talking about those as we talk about things going across membranes, etc. And then I need you to know, and this is a chemical reaction, it'll come back to us. So might as well start memorizing this. This is called cellular respiration. It's how we make our ATP energy. I can't spell all of a sudden. Cellular respiration. It's going to be how we make our energy. And so what we're going to do, some of you, again, not having chemistry, don't know your parts, but so this over here, this side is always known as the reactants. And this side over here is known as the products. The arrow means yields or to make. So reactants yields products. The way you can remember that, because students mix them up, is RAP, reactants, arrow, product, RAP. So the reactants yields the products, RAP. Because you know I got to have some fancy way to remember it. All right, your pH scale pretty much goes from 0 to 14, with 7 sitting in the middle. pH is whether something's an acid or a base. The lower your number, the more acidic. 7 is neutral. It's not just water. Water is supposed to be a 7, but not all water is 7 because not all water is pure water. Pure water is supposed to be 7. Okay. The more you go to the bigger the number, you get more base, more basic. Okay. So if I asked what's more acidic, a 6 or a 2, you would tell me a 2 is more acidic. What's more basic, an 8 or a 12? You would say a 12 is more basic. Okay, there are questions like that. The pH of your blood is actually slightly basic, and I would like you to know the range, 7.35 to 7.45. Slightly basic. Close to neutral, but slightly basic. And you try to stay in this range. The lower you get, if you get too low with that, is something called acidosis. If you get too much acidic in your blood, you'll die. So if you get your acidosis level is too low, so I think like below a 7, I don't know the actual number, I used to, you'll die. So when you put things in your body and take different drugs or medicines or things that can mess with your blood pH, you can kill yourself. Too acidic. Alkalosis, which means alkaline, is basic, is getting above this number here. If you get too far above that, you're also going to die. So you can die over here and die over there. So your blood likes that homeostasis to try to stay really close to there. What makes something acidic is what we call hydrogen cations. So H plus 1 ions. So hydrogen ions. That's a cation, by the way. What makes something basic is this is actually an ion as well. It's an OH. Let me do it this way. I'm used to just doing that dash on that one. 1 minus charge. This is something that, and this is called hydroxide. I left out my R. So if you get a lot of hydroxide ions, something becomes basic or also called alkaline. So if you see that word alkaline, that means basic. If something's acidic, it has more hydrogen ions. Water has both of these ions, so which is why water is neutral. Because we write it as H2O, but it's kind of what it is. Okay? That's what I need you to know about the pH scale. And then we are going to next unit, well, not next unit, but part 2, we're going to go in detail of the 4 organic compounds. And we are going to be talking about carbohydrates, we're going to be talking about lipids, proteins, and nucleic acids. And that will be our next lesson, and I will try to make a video of that very soon. Okay, that is Chapter 2, Part 1. Please email me, or if you have any questions or concerns, have a great day.